Greetings, my fellow Almontians, and welcome back to another broadcast from the bunker. Today's hot topic will be the rock cycle. Good stuff. All right, so in the meantime, today's due now is numbers 17 to 20 in the GC. Please crank those out, and I'll be right back with you. All right, so again, I hope you put some good love into those like you always do. Start out on number 17 here. Which statement best explains the apparent daily motion of the sun? Well, remember, when you're talking about daily, they're referring to the Earth's rotation. If it said annual, you'd be thinking about the Earth's revolution. So in this case, how do you explain the apparent daily motion of the sun? Well, we know the sun rises in the easterly direction, sets westerly. There are 2 days a year, if you recall, where it rises due east and sets due west, and those are your equinox days. Very good. But that apparent daily motion is a result of Earth's rotation. And if you recall, the Earth rotates at a rate of 15 degrees per hour, so that's the speed at which the sun goes across the sky as well, the rate at which it goes across the sky. So we're going to go with Earth's rotation here. And please make a notation of that 15 degrees per hour. Okay. All right, let's go to number 18. Okay. Number 18 over here says, in the diagram below, the direct rays of the sun are striking the Earth's surface at 23.5 north, aka the Tropic of Cancer. What is the date shown in the diagram? Well, take a look. The entire Arctic Circle is lit up, right? The North Pole is tilting towards the sun. So that's that magical summer solstice day, right? That June 21st. So right there, choice D. All right, I'm going to write in there SS. You recall that's summer solstice. You can see the entire Arctic Circle is illuminated, and that's what helped you with that answer. All right, number 19. The diagram below shows the sun's maximum altitude relative to a vertical stick in New York State on June 21st. Again, there's that magic day, summer solstice. In which direction from the base of the stick does shadow C prime point? Well, here's C prime. Here's the stick. Here's sunrise. Here's sunset. We know the sun rises generally in the east, sets generally in the west. And we know that at solar noon in New York State, the sun will be in the south. So if the sun is in the south, the highest point of the day right there, solar noon, well, if that's south, then the shadow must be going towards the north. And that's, of course, why we talked about why moss will grow on the north side of a tree, right? Because the direct sunlight is hitting the south side, and it cooks it. It evaporates all the moisture, but it can survive on the north side because it's in shade, it's cooler, there's more moisture. And that's one of those ways they tell you can find yourself if you're lost, right? Find a tree in an open area, and wherever the moss is growing is probably the north side, if you're in the northern hemisphere. All right, so let's get that answer down there. North. If you remember, this is also how the sundial worked. This would be about 12, this would be about 6, this would be about 3, and this would be about 9, right? If you want to put your compass points in there, this would be south, this would be north, this would be west, and this would be east. Okay? All right. And the last one there, number 20. New York State has several more hours of daylight in the summer than in the winter. Now we're talking about a seasonal thing here. That's a yearly thing. Which statement helps explain this observation? Well, if you're talking a yearly thing, you got to be talking about the Earth's revolution. So it's got to be an answer that includes something like that. Distance between Earth and the Sun varies. Well, that's true. That's the elliptical orbit, but it doesn't answer this question. Speed of the Earth on its orbit changes. Well, that's true. Once again, because of that elliptical orbit, right? If you're closer to the Sun, you're going to go faster, further away, a little slower. But again, that doesn't answer this one. So it's got to be a yearly thing, but also the tilt. Remember, we have seasons because of the Earth's tilt as it revolves. If the Earth were not tilted, then every day would be an equinox day, and we'd have 12 hours of daylight, 12 hours of nighttime. We'd be in the same season all year round. So yeah, you got to go with tilt on this one. That's giving us different seasons and also different length of day and night throughout the year. You guys remember how much the Earth's axis is tilted? 23.5 degrees. That is, of course, why we refer to the Tropic of Cancer and Capricorn. They are 23.5 degrees north and south, and that is directly related to the tilt of the Earth as well. All right. Again, if you have any questions on that, put them right down in the YouTube link, or you can shoot me a remind. It's up to you. Let's jump into the lesson. All right. Your homework this evening. Textbook, read pages 113 to 116. I'm looking for 15 bullets. There's a little bit of a network issue today. I'll try redoing the subtitles, but it might be a little tricky here. All right. If they do cut out, I apologize. Again, a lot of traffic on the internet seems to be slowing everything down. Okay. As far as your textbook homework, write it down on paper, take a picture of it, and email it to me as soon as you can. All right. Hopefully, you guys previewed the lesson in the GC. I'm going to go through this pretty quickly, so if you need to go back or pause, do what you got to do. Okay. Quick little video, a little summary on all the rocks we've studied. Check it out.
You know, Globey, here on Earth we have three basic types of rocks: igneous, sedimentary, and metamorphic rocks. Scientists classify these rocks by the way they were made. Igneous rocks are formed when lava from a volcano cools and hardens. Igneous rocks are also formed when magma cools below Earth's surface. Sedimentary rocks are formed when the elements wear rocks down into tiny particles of dust, sand, and soil. Wind and water help move these particles around and deposit them into layers. As time passes, these layers are cemented together and harden into new rocks. Metamorphic rocks form when sedimentary or igneous rocks change after being exposed to extreme heat or pressure without melting. As conditions on Earth change, rocks may change from one type to another. Sedimentary rocks can change into metamorphic rocks, or, if they melt, into igneous rocks. Igneous rocks can change into sedimentary or metamorphic rocks, and metamorphic rocks can change into sedimentary or igneous rocks. Scientists call these changes the rock cycle.
All right, that's of course what we're jumping into today, the rock cycle. Okay. Little reading here. Please take a minute, pause it, read it on your GC there. Some interesting information. Here's our classic rock cycle. I hope that looks familiar to you. That's straight out of the reference tables. And we're going to follow the paths of that into each different type of rock. But in general, write down your definition. A rock cycle is a never-ending cycle that shows the different type of rocks and how they change from one into the other. Okay. There are three basic driving forces behind all this, and you can probably figure out most of them. The first, of course, energy from Earth's interior. Earth is still hot on the inside, and that heat wants out. And in its journey to the surface, it makes all the continents move, and they bang together, and you get a lot of what's called uplift, a lot of motion, and that can change the rocks. Okay? Energy from the sun, right, drives the water cycle. The water cycle is responsible for weathering and erosion, and that too will change rocks. All right, and of course, don't forget gravity, right? When something breaks at a higher elevation, gravity will pull it down, and you'll start to make sedimentary layering, right? Layers, one of those big characteristics of sedimentary rock. Okay. How do rocks differ from one another? Well, if you take a look, origin is big, right? How they form, where they come from, also what minerals they're made of. Rocks are different based on their origin and their compositions. All right? How do we define a rock? Well, in general, it's a substance composed of one or more minerals. If it is one mineral, they call it a monomineralic. Mono, the prefix means one. For example, rock salt is mostly made out of halite, so it's a monomineralic sedimentary rock. Limestone, also a sedimentary rock, mostly made out of one mineral called calcite. Unlike granite, for example, over here is a polymineralic. Poly, the prefix means many, and you have many different minerals in there. Quartz, mica, feldspar, biotite, amphibole, a whole bunch of different minerals in that rock, so it's poly. Okay, recapping igneous rocks. Remember, igneous rocks start at magma or lava. They get pushed up, or they rise up to the surface eventually. They'll cool, crystallize, solidify into igneous rock. If they cool slowly, you remember, they get bigger crystals. If they cool quickly, smaller crystals. So there it is. Igneous rocks formed by the cooling and solidification of hot, melted, molten rock. Magma down below the surface, lava on top of the surface. The minerals will crystallize as they cool. And once again, magma from below, lava above. All right. I don't know if you remember that movie, Austin Powers. He was kind of a funny dude, but Dr. Evil was his nemesis, and Dr. Evil was always looking to destroy the world, and at one point, but he always makes mistakes, and at one point he says, I want to cover the world in liquid hot magma. And of course, that's just silliness, because if you're covering the earth, it must have exited. He should have said lava. So anyway, funny movie. Check it out if you have a minute. So now we jump into sedimentary. This is the same rock cycle, but now we're going this way. We're breaking down weathering and erosion into sediments. You can re-weather them, break them even smaller into sediments, and ultimately they'll get buried, deposited into those layers, and compacted and cemented into sedimentary rock. Okay? Sedimentary rocks, there it is, formed by compaction and cementation of layers and cement. There is one classic sedimentary rock that doesn't need cement. You played with it as a kid. Of course, the material I'm talking about is clay, and clay turns into shale. It does not need to be cemented. It just gets compacted and the water evaporates, and you make a sedimentary rock. There's your gorgeous layers right there. The deeper you go, the older the rock gets, unless it's been flipped over, of course. And that's very helpful when you're figuring out the age of fossils, because if there was one up here versus one down here, you can tell who was relatively younger or older without even trying to get an exact date yet. And we'll get to that later in the year. All right. Finally, we talked about metamorphic rocks, and yes, you guessed it, if you keep going, you'll end up there, but you don't have to go straight from sedimentary. You can go from igneous to sedimentary. You can go from sedimentary to metamorphic, and of course, you can re-metamorphose into a different metamorphic rock. Remember, we talked about how slate could become phyllite, phyllite schist, schist gneiss. Well, those are all metamorphic rocks, and they can be re-metamorphosed into as such. Okay? And there it is, rocks formed from pre-existing rocks. They change by heat and pressure. You get this big word here, recrystallization. They do not melt. If they do, they go back to igneous. But they make these gorgeous, you can see these bands here, right? Foliations that get distorted are called bands. They often tend to be very shiny, like we said in the metamorphic lesson. If you zoom in on those are little garnet crystals. They look like rubies. They have a beautiful reddish color. You can polish them into like a gemstone. They're not as hard as rubies. They won't, cost as much, but they're absolutely gorgeous. That's a garnet schist. That's a gneiss. And these are just other metamorphic samples. Very, very pretty rocks. All right. So here, take a minute, pause the video, try to put these 3 questions onto this chart here. Take a minute. Try restarting the titles there again. I apologize, but the network is causing issues with the translation. All right, so here we go. State the type of rock that you would form at A, B, and C. Well, A, B, and C, let's see. Magma, cooling underground, that's got to turn into igneous, right? Okay. I'm jumping out of order here. So that's rock A. Rock B, you're getting high-grade metamorphism. So obviously we're talking banding. That's metamorphic, right? So you got metamorphic. And C, I jumped out of order, was igneous. Compaction and cementation was your sedimentary. All right. Describe the path, the formation an igneous rock would experience to form a sedimentary rock. Well, here's your igneous rock. To become sedimentary, you got to be broken down into sediments. Then you get compacted and cemented into sedimentary. All right. And that's what's going on right there. And the third question on there, state one process that would cause the high-grade metamorphism of rock A. Well, how do you get this to metamorphose? You need extreme heat and pressure, right? Maybe recrystallization is a word you might see. Either way, extreme heat and pressure to turn into a metamorphic rock. Okay? Hopefully you did okay on that. We'll hit a couple of summary readings questions. Finish strong here, folks. Which statement about the formation of a rock is best supported by the rock cycle? Well, when you look through them all, hopefully you came up with right here, sediments must be compacted and cemented before it can become sedimentary. That is your best statement, of course, that answers that question. On down here, which type of rocks can be the source of deposited sediments? Well, remember, any rock can be broken down into sediments. So anything that says any rock, and there it is, all of your rocks right there. Rocks are classified as igneous, sedimentary, metamorphic, based primarily on, well, what separates them, right? How did you figure out which one was which? And its method of formation, right? If it's igneous, it came from magma or lava. If it's sedimentary, it came from other rocks broken down, cemented together, etc. Number 4, rocks can be classified as sedimentary, igneous, or metamorphic, based primarily upon differences in, well, pretty much where they come from, right? How they were formed, where they come from. And this last one here, I know it looks like it probably had 2 good answers. The main difference between sedimentary and non-sedimentary rocks, hopefully you were between 2 and 4. Locations in which they are found, well, sedimentary are usually at the surface, but other rocks can be at the surface as well. Conditions in which they are formed, however, that will stay the same for each rock. So that would be your better answer there. Okay. And the last few here. Describe what all rocks have in common. Well, they all have minerals, right? They all had to undergo certain processes. For your second one here, describe the difference between the formation of igneous, sedimentary, metamorphic rocks. So hopefully you can go through and explain how each rock is formed. Okay, go back to the rock cycle if you need to, for the vocabulary if you forgot it. How are mono meaning one, and poly meaning many, how are they different? All right, well, there you have. Mono, just one mineral, poly, many minerals. And, of course, describe the path a rock might experience from igneous to metamorphic. Again, go to your rock cycle, find the words between igneous and metamorphic. Write a few words in, right? Recrystallization, add that to your sheet. Metamorphism, all that good stuff. All right, folks, hope you're doing well. Remember, if you do have questions... Oh, let me get my question page up here. Oh, can't seem to find it at the moment. But remember, if you do have questions, go to bottom of the YouTube channel here and write them there, or send me on Remind. Okay, take care.